Which statement gives the numerical value of the Avogadro constant? A. The number of moles in 12 grams of carbon 12. B. The number of electrons lost by 20.05 grams of calcium when it reacts with oxygen. C. The number of molecules in 16.0 grams of oxygen. D. The number of atoms in 1 mole of chlorine molecules. So let's start this question by identifying Avogadro's constant. So Avogadro's constant is 6.023 times 10 to the 23. So if we look at the different options, looking at A first, we're going to use the equation triangle of mass divided by relative formula mass times moles to work out the number of moles in 12 grams of carbon 12. So we do 12 divided by 12, which equals 1 mole, which is not Avogadro's constant, so the answer is not A. Next, looking at B. So this question requires a little bit more calculation. So again, using the equation triangle to work out moles, we've got 20.05 grams of calcium, and we're dividing it by its relative formula mass of 40, and that equals 0.5 moles. And this is equivalent to the loss of 1 electron. But when we form calcium oxide, we lose 2 electrons. So we're going to multiply this by 2, so 0.5 times 2 is equal to 1 mole. But this question isn't asking about moles, it's asking about the number of electrons lost. So to work this out, we multiply the number of moles times Avogadro's constant, and as we're multiplying by 1, we're going to get Avogadro's constant. So this means our answer is going to be B. But with multiple choice, we need to check all of the options to make sure that this is correct. So looking at C next, so we're again using the equation triangle. We're going to do 16 divided by 16 times 2, because oxygen naturally occurs as O2. So dividing this by 32, we end up getting 0.5 moles. And we want molecules, the number of molecules in this question, so we need to multiply by Avogadro's constant. So 0.5 multiplied by 6.023 times 10 to the 23 is equal to 3.01 times 10 to the 23. And this is not Avogadro's constant, so it's not C. Finally, looking at D, the number of atoms in 1 mole of chlorine molecules. So in chlorine, we're going to have Cl2. So we're going to have 2 mole equivalents. So we're going to do 2 times Avogadro's constant, which again is not going to equal Avogadro's constant. It's going to equal 1.204 times 10 to the 24, which is not the answer we're looking for, so it can't be D. Therefore, our answer is definitely B, so we can write this in the answer box provided, and to get the mark for this question, you need to write B in the answer box provided.